So now I'm going to start chapter 12, which is about sequences and series. Uh, 12.1 is about general sequences in general. What is a sequence? We're going to talk about finite versus infinite sequences. So let's define first a finite sequence. A finite sequence is a function. So sequences are nothing but functions, but their domain is restricted, whose domain is the set of first n counting numbers. Like could be first 10, first 100, but it has to end somewhere. So there's no negatives in the domain. You can see the first number is 1, 2, and so on. So these are the counting numbers less than or equal to a fixed counting number n. N is a fixed counting number. Like I said, could be 5, could be 10, could be 500, but it has to end somewhere. So this is finite sequence. An infinite sequence or infinite is a function whose domain is the set of all counting numbers 1, 2, 3, 4 up to it's an infinite, so it's the set of all counting numbers. So let's just see the difference between functions and sequences. So we see the transition, and like this is f of x equals x squared. This is a sub n equals, so we use n as an index, n squared. F of 1 is 1 squared, a sub 1 is 1 squared. F of 2 is 2 squared, a sub 2 is 3 squared. Here we can do negatives. No negatives there, that doesn't make sense. Okay? The A's are called terms of the sequence. So A1 is the first term, A2 is the second term. The general term is called the nth term of the sequence. Just like f of x is the formula for a function, an is the formula or the nth term of a sequence. So number 10, page 851. If you look at number 10, page 851. It says 10,850 actually. We're given an is 1 over n squared, and we need to find the first 4 terms and the 100th term of the sequence. The first 4 terms, so the first one is 1 over 1 squared, the second one, so we're plugging it the numbers n. A3 is 1 over 3 squared, 1 over 9. A4 is 1 over 4 squared, 1 over 16. And the 100th term is 1 over 100 squared, which if you do 100 squared, you get 1,000. I mean, you could have your calculators spell all these out for you. So if you go to mode, and we're going to change function into sequence. So you go all the way to sequence, highlight, hit enter. Now you go to y1, so you can see it changed. The minimum value is, the n minimum is 1 because that's the first value. And then u of n is going to be 1 over n. It's the same value as x, that's n squared. And then hit second graph, and it's gonna show you, oh, u minimum is, I don't know what's wrong, why it's doing this. U minimum should be 1, I don't know what's wrong with this. N minimum is 1, u of n is 1 over n squared. No, I'll have to see why. It's 1 over. Table set. Here we go. Okay. So I had to do table set starts at 1. I had to do auto instead of ask. And that's U1, U2, U3, and so on. Okay. Now, some sequences are defined recursively. What is that supposed to mean? So, recursively defined sequences. So, what does a recursively sequence gives? The nth term, like the 100th term, the 50th term, as a function of the n minus first term, which is the preceding term, okay? The n minus first term. So for example, the nth term, instead of it's given in terms of n, it's given of the preceding term, which is n minus 1 over 3, and you need to be given the first term so you can start. So if the first term is -8, then the second term, if you put n equal 2, and you get a2 equals a1 over 2. So you can see you need the prior term to get to the next term. As in the regular defined, you don't need the prior term. You can find the 100th term, okay? At any time. So n equals 3. To get the third, you need the second. Look, a3 is 2 over 2, which is -4 over 2, -2, and so on. Now, in the calculator, you can have it do that for you. Here. You could go y equal, and u minimum is 1. U of n is going to be u. So you gotta go to u, which is right there, number 7. So you do second, number 7 of -1 n minus 1. Let me delete the square from there. U of n is u of n minus 1 divided by 2, right? an is an minus 1 divided by 2. Now a1 is -8, so u of 1 with a1 is going to be -8. And then to find u of 5 per se, go to screen, or you can just go to second table, and it will show you u1, u2, u3, u4, and so on. It will list all the values for you. Okay, number 36, page 851. 36, page 851. We're given 3/4 sequence, 4 over 5, 5 over 6, 6 over 7, and it's infinite. It doesn't end. And it says find the nth term. So we're given this by the terms of the sequence, and we want to find the general term. So you can see this is 3 over 4, 4 over 5. So the first term, 3 over 4, which is 1 plus 2 over 1 plus 3, right? 1, 1, 1. This is a2 is 2 plus 2 over 2 plus 3. a3 is 3 plus 2 over 3 plus 3. So an is going to be n plus 2 over n plus 3. If you see that, okay? That's the general term. Now, what are the partial sums of a sequence? When we say partial sums of a sequence, for sequence A1, A2, A3, A4. So obviously there's addition, right? The partial sums are the first partial sum is the first term. You can't add anything to that. The second one is the first two, 1 plus A2. The third is the first three, 1 plus A2 plus A3. The fourth is you add the first four. You always start with the first and end with that index. And then the nth is A1 plus A2 plus A3 up to that nth. Could be 100, could be 50, we don't know. It's called the nth partial sum. The nth partial sum. So number 44, page 851. We have n is 1 over n plus 1 minus 1 over n plus 2. And they want us to find the first four partial sums and the nth partial sum of the sequence n. So the first four, so S1. S1 is the first term, which is 1 over 2 minus 1 over 3, which would be 1 over 6. The second partial sum is A1 plus A2. See, A1 is right there. We'll try to find a pattern. A2 would be 1 over 3 minus 1 over 4. You can see these cancel out. It's 1/2 minus 1/4, which is a fourth. The third partial sum, which is A1 plus A2 plus A3, which is 1/2 minus 1/3 plus 1/3 minus 1/4 plus the third one, which is 1/4 minus 1/5. You can see it's telescoping, so it's 1/2 minus 1/5, which would be 3/10. The fourth partial sum, A1 plus A2 plus A3 plus A4, so it's going to be the first minus the last, minus 1 over 6, right? Which would be 1/3. And then the nth, as we can see, it's going to be 1/2 minus 1 over n plus 2, which is n over 2 times n plus 2, right? The first, if you put a 1 here, and then the last, if you put an n, according to all the what we see. Okay, to find the sum, this is what you can do. The nth partial sum, you can go to math, and then go up to 0, and then you can add, say for this one you can add, if you want to find S4, you can do n equal 1. So you do n equal 1 up to 4, and then we can end that sequence 1 over parentheses n plus 1 minus 1 over parentheses n plus 2. So if you want to find the first four, here they are. They're 1/3. Right there. You got 1/3. Okay, and so on. Now the sigma notation that you saw. So if you're adding 1 plus A2 plus A3 plus AN, you write sum from n from I equal 1 to n AI, and that's going to give you all of that. Okay, so 48, page 851. What's the sum from 1 to 4? K equal k squared. You plug the 1 in, you get 1 squared plus, sigma means sum. Plug the 2 in, 2 squared plus, you plug the 3 in, and then you put the 4 in, and you stop because that's where you have to stop. And then you add them up. 1 plus 4 is 5 plus 9. 14 plus 16 is 30. And I just showed to check it with your calculator. Sigma j equals 1 to 100, negative 1j. So if you put a 1 there, negative 1 to the 1 is negative 1, plus if you put a 2, it's negative 1 squared, which is a 1. If you put a 3, it's negative 1. 4, it's 1. So each pair is 0, and you can see that the 99th one would be -1, the 100 would be 1, so the answer is 0. Now let's look at 64. Sum from k, so we don't start at 1, we can start somewhere else. Here we're starting at 6. If you put 6 in there, 6 plus 3 is 9. 7 plus 3 is 10, and then 8 plus 3 is 11, and then 9 plus 3 is 12. If you do the math, it's 320. Just simple calculation. 68. And 68, it says write the sum using sigma notation. So usually they give us this and they want the answer. Now we're given the individuals, and we want the sigma notation. Plus 29. So this is when n is 1, it's 2. When n is 2, it's 5. When n is 3, it's 8. So a1. So how do we? So this is like 3 minus 1. This would be 6 minus 1. This would be 9 minus 1, right? So 3 times 1 minus 1, 3 times 2 minus 1, 3 times 3 minus 1, and then an would be 3 times n minus 1. So this would be sum of 3n minus 1. Now if you start at 1, you get the first one, and then you're going to end up at 10. You get 30 minus 1, which is 29. Number 70, 1 over 2 ln of 2 minus 1 over 3 ln of 3 plus 1 over 4 ln of 4 plus 1 over 5 ln of 5 plus 1 over 100 ln of 100. How do we write the sigma notation? Again, this is A1, A2. You can see they alternate, so we need a -1 to the I. This is if -1 to the I, because if you start, you can start at 2, it's going to give you positive. At 3, it's -1 cubed, it's going to be negative, and so on. Now this one, so A1 is 1 over 2. So the first term is, so we need 1 over 2. So it's, if it's a 2 here, so it will be I ln of I. So 2 ln of 2, 3 ln of 3, 4. It will give me that, and then it's gonna stop at 100, and that will give you the notation. Now let's look at some properties of summation. Let's look at properties of summation. If you sum from 1 to n of a constant, it's Cn, where C is a constant. Why is that? Because when I is 1, you get C. When I is 2, you get C. When I is 3, you get C. And then when I is n, you get C. How many C's? N C's. If you're doing I equal 1 to n CAI, where C is so it's CA1 plus CA2 plus CAN. You can pull the C out, and this is 1 plus A2 plus AN, which is C sigma AI. So when you have a constant, you can pull it out. And if you're doing sum of AI plus BI, remember this is A1 plus B1 plus A2 plus B2 plus AN plus BN, which you can rewrite as A1 plus A2 plus AN, and then plus B1 plus B2 plus BN, which you can break down the summation notation, sigma AI plus sigma B. Same thing with the minuses, okay? And finally, if you have the first m terms, and then from m plus 1 to n, AI, it's the same thing as from 1 to n. AI. Okay, that's easy to see. So let's look at 80, page 852. 80, page 852. Let's see what it says. Paying off a debt. Margarita borrows 10 grand. So the original amount she borrowed is 10 grand. From her uncle, agrees to repay it in a monthly installments of 200. Her uncle charges 0.5% interest per month on the balance. Show that her balance AN in the nth month is given recursively by A0 equals 1000 and AN is 1.0005, AN minus 1 minus 200. So this is at t equals 0. This is when she borrowed the one. T equal 1, the 1 month. So she's gonna be paying so she's paying 0.5%, right? 0.5%, which is 0.005, and then 100% is 1, so it's going to be paying 1.005 A0, and then it's minus the 200, right? The first month. The second month, it will be 1.005 A1 minus 200. The third month, it will be 1.005 A2 minus 200. So at t equals n, an is 1.005 an minus 1 minus 200. Is that what they want? Perfect. Find her balance after 6 months. So you can do that after 6 months. Okay, that's yours. It's in there. A6 is $9,088.68. And you can put it in your calculator. I have it all here. And that ends 12.1. So 12.2 is more structured sequences, arithmetic sequence. It's more fun. We'll talk about it next time.